This is a review of the tension wrap-up problem number 2. Hey, in this case, a couple things to take a look at. One is that all the systems are at rest, so we know forces are balanced. 2, in A and B, the blocks rest on frictionless surfaces. On D, there's an upward force on the block. Okay, so on A, we have a tension of 80 newtons to the right, so our tension to the left must also be 80 newtons. B, the situation is similar to A. We have a tension, or we have a force 45 newtons to the right, so we must have some type of a force or tension 45 newtons to the left. Might wonder, hey, what does this 30 newtons have to do with it? 30 newtons is a gravitational force down. It doesn't influence the force right or left. So this force of gravity would be balanced by a normal force up. Hey, in C, we have a force of gravity of 80 newtons down, so we must have a tension force of 80 newtons up. On D, we have 120 newtons down. Okay, and we're going to have to balance that with a total of 120 newtons up. We have 40 newtons of normal force up, so we're going to have another 80 newtons to balance that. Okay, let's move on to E. Okay. In E, we have 60 newtons down, so we must have 60 newtons of tension to balance that. That 60 newtons is going to be pulling down on that 40 newton mass. Okay, so we're going to have the 40 newtons of weight plus the 60 newtons of tension. We have a total of 100 newtons down, so our tension up must be 100 newtons. Let's move on to F. Okay, similar situation. We have 40 newtons down for gravity, so we must have 40 newtons of tension in the rope between the lower and upper masses. We have 40 newtons of tension down, plus the 40 newtons of weight down, so that has to be balanced with a total of 80 newtons of tension up. Let's move on to G. Hey, looking at the object on the right side, we see that there is 80 newtons of gravity down. The only other thing holding it is the cable, so there must be a tension force of 80 newtons. Okay. We'll trace that all the way through. We know that 80 newtons has to be the same all the way across in a rope or a cable. That'll do a nice job of balancing this force on the left side, that gravitational force, so we have 80 newtons down. You might suspect there might be 160 newtons of tension at R, but remember it's a single cable, so we know that there's 80 newtons of tension throughout the entire object. Let's take a look over on H. Similar situation. We got 40 newtons of gravitational force down, so we must have 40 newtons of tension pulling up on that. The cable has the same tension throughout. That'll balance that 40 newtons on the other side, so we must have 40 newtons of tension throughout. Okay, not 80 newtons, 40 newtons. Okay. Let's go and see how we're going to rank this. Okay, we can see that we have 100 newtons of tension in E. Now let's go ahead and gather all the 80 newton tensions. That'll be A, C, D, F, and G are all at 80 newtons. The next one is B at 45 newtons. And then finally our least tension is 8 at 40 newtons. Hey, good luck with this. Hope you do well. Check your answers.